Hello folks, welcome to the third video in the polynomials unit. In this video we're going to be talking about two things. We're going to talk about how we add and how we subtract polynomials. So we can perform operations if I had multiple polynomials, and it ends up being almost exactly the same as what we were looking at in the previous video, which is combining like terms. So what ends up happening is if I want to add polynomials, very simply, if I have the polynomial 7s plus 14, right, I have this 1 degree binomial, and I have the polynomial negative s squared plus s minus 6, 2 degree trinomial, and I wanted to add these polynomials together for whatever reason. Maybe there's some context to it, maybe there is a method or a reason that we want to do this, but whatever reason, we're trying to add these things together. Realistically, all we're really doing here is we're just combining like terms. I'm looking up this polynomial and I'm seeing that I have s's and I have constants. And I'm looking at this polynomial and I'm seeing I have s squareds and s's and constants. I'm going to find those like terms and I'm going to add them together. Now, there's two ways to do this, and they're arguably the same strategy, just kind of looking at it a little differently. And maybe some of you do this when you're doing additions and whatnot, but strategy number one is I could do this just normally. I could do it horizontally. 7s plus 14 plus negative s squared plus s minus 6. Step one, just remove the brackets. The brackets aren't really doing anything. Right now, all they're telling me is that this is its own polynomial and this is its own polynomial, and I want to add them together. But now that I recognize that, the brackets aren't doing anything, so we can remove them. So that's our first step. Step two is to combine like terms, just like we did in the last video. So we want to look for all of our s's, all of our s squareds, and all of our constants, and we want to group them together. Right, so I only have an S1 term that is an S squared term, so we'll put that one first. And then I see that I have two S terms, so we'll group those together next. And then I see that I have two constant terms, and we'll group those together at the end. And then finally, my last step is to do the addition. So I have negative 6s squared. There's no other s squared, so that's just negative 6s squared. I have 7s plus 1s, so 7 plus 1 gives me 8s. And I have a 14 minus 6, so 14 minus 6 is 8. So there's my result. Method number two is to do it vertically. Exactly the same operation, but instead of having to rearrange, what I do is I align everything together in vertical columns. So as I'm writing out these polynomials, I write them out in a way that's going to line up my constants with my constants, my s's with my s's, and my s squareds with my s squareds. So I can kind of skip the step of having to rearrange in order to group like terms by writing it out in this way. And I do the same operations, right? Negative 6s squared turns into negative 6s squared. 7s plus 1s gives me 8s, and 14 minus 6 gives me 8. Now, I can also do these things using algebra tiles, right? Same thing. So if I want to take this 5g plus 3 and I want to add it to 2g plus 4, well, step one is I need 5g plus 3. Oh, those are g squared, sorry. I'm not even paying attention to my own question. 5g, so 1, and let me just copy paste this. 2, 3, 4, 5. 2, 3, 4, and another one makes 5. I don't know where the fifth one went, but there we go. And then plus 3, so 1, 2, and 3 of them. And then 2g plus 4, so 1, 2g plus 1, 2, 3, and finally 4. There we go. So the idea of addition when it comes to algebra tile, you're just smashing the two groups together, right? I'm just taking these two groups of tile and I'm putting them together. So my s's or g's go together and my 1's all go together, and now we're simply just going to count. So I have 1, 2, 3, 4, 5, 6, 7. So there's 7 g's, and I have 1, 2, 3, 4, 5, 6, 7, and 7 1's, so 7g plus 7. And then the same thing can be done for question B. Again, all I'm doing is I'm just making these algebra or these polynomials using my algebra tile. So 3 minus 2j, so 1, 2, 3, and then we're going to minus 2j. So we're using our negative algebra tile, so minus 2j, and then negative 4, 1, 2, 3, 4, and we're going to plus 2j. So 1, 2. And again, all this then tells us to do is to group these together. Now, the difference here is instead of adding them up, we're going to find our 0 pairs, right? So I have 2 positive j tiles and I have 2 negative j tiles. So there's one of my 0 pairs, so they go away. And I have 3 positive 1 tiles and I have 3 negative 1 tiles. So there's a 0 pair and it goes away. And it just leaves me with negative 1. Okay, so when we're using algebra tiles, right, we're just taking the two polynomials and we're basically just smashing them together into one. The only other thing we need to be made aware of, just like the last video, where when we're working with two variables, because it's done exactly the same way, we have to deal with it exactly the same way. So when I'm looking at this polynomial, I'm thinking to myself, okay, what's going to add, what's not going to add? I'm combining like terms just like I was if there was no brackets there. So if I have 2a squareds, I'm looking anywhere else. Do I see any other a squareds? Oh, yep, there's one there. So plus 5a squared. And then plus a, any other a's? Oh, there's one there. So minus 5a, minus 3b. And again, I'm looking through. I see I have a plus 6b on this one, minus 7ab. So again, come over here. I've got a 3ab. And then finally, plus 3b squared. And I see that I have a minus 4b squared. So all I did was I made sure that every time I have some kind of unique variable, so a squareds or a's or b's, I just look through everywhere and I see if there's any other examples of that same variable, right? So now that I have them all matched into their like pairs, we're simply just going to add coefficients. So 2a squared and 5a squared gives me 7a squared. 1a and negative 5a gives me negative 4a. Negative 3b and 6b gives me positive 3b. Negative 7ab and positive 3ab gives me negative 4ab. And then finally, 3b squared minus 4b squared is minus 1b squared. And there we go. So moral of the story here is if you are adding polynomials, right, we can do it in kind of two ways. We can either do it using the algebra tiles, where we're kind of taking one and we're making it using algebra tiles. We're taking the second one, we make it using algebra tiles, and we just smash that group together and we combine like terms. If we're doing it symbolically, we're rearranging to make sure that our like terms are together. And again, we're adding like terms. Now, be careful. Adding polynomials is simply just combining like terms, whereas subtracting polynomials has a bit of a step in between before we do that. So if you had the numbers negative 2, minus 3, and I said subtract those for me, we should have some kind of way of dealing with that. And what I have found throughout the years is sometimes we get a little confused. We think, oh, a negative and a negative makes a positive, right? And the answer is, well, not in this case, right? So we have to understand what it means to subtract. And quite honestly, we should be thinking about all these operations as additions. Negative 2 minus 3 is the same thing as taking negative 2 and adding to it a negative 3. And it may seem like this really weird, like, why did he do that step? But it's helping us understand what we're actually doing here. It's really easy to take this and to make that mistake of saying a negative gives us a positive. But if we understand it in this way, where I'm taking something that's negative and I'm making it more negative, I'm adding a negative to a negative. So think about it in like a real world context. I'm thinking something cold and I'm making it more cold. That's not going to all of a sudden make it hot. Or if I lost money and I lose more money, that's not going to put $5 in my wallet, right? So we have to understand these things and what it means. So whatever strategy you would use to do this type of subtraction can actually be helpful when we're looking at polynomials, because if we start thinking about these as simply just subtractions, sometimes things can get a little confusing. So let's take a look at an example where it's kind of easy to do something like that in this one here. So if I look at the algebra tiles that are modeled here, what do I have? I have negative 2x squared plus 4x minus 2. And it's asking me to subtract or to take away the things that are highlighted. So we're being asked to take away and negative x squared. We're being asked to take away a 3x, and we're being asked to take away a negative 1. So if I do that, what am I left with? Well, I'm left with this negative x squared, I'm left with this x, and I'm left with this negative 1. So there's my result, right? Negative x squared plus x minus 1. It's really easy as long as I have the tiles to take away. So if I want to perform a subtraction using algebra tiles and I want to think about subtraction as takeaway, I can do that. The problem lies, though, is when I don't have enough tiles to take away. And I'll show you what I mean here in a second. But let's take a look at this one, this part B. So again, as a polynomial, these algebra tiles represent positive x squared minus 1, 2, 3, 4, 5x, and minus 4. And then from that, we're being asked to take away an x squared and 4x's and a negative 2. So we do that, and what are we left with? We're left with just that negative x, and we're left with these negative 2's. So we get negative x minus 2. Again, not too bad representing this algebra or pictorially as algebra tiles, because the x squared I have is also what I'm removing. And the negative 2x squareds, I'm removing one of those negative x squareds. But what if instead of being asked to remove something you already had, you were asked to subtract something that wasn't there already? So what I mean by that is, what if I asked you to do this one? Negative 2x squared, or sorry, negative 2a squared plus a minus 1, subtract a squared minus 3a plus 2. So again, if I wanted to do this as algebra tiles, well, negative 2a squared, 2a squared, but the problem is it's asking you to then subtract or to take away a positive a squared. Well, I don't have any positive a squareds here to take away from, right? So that's the problem with these types of questions, is once I start trying to subtract something that wasn't already there, then I run into a problem of, okay, well, what do I, or how do I actually subtract it? And now it comes into that part where it's like, okay, well, what was your strategy beforehand? Because if I said 3 minus 2, well, that's okay to think about and be like, okay, well, all that means is I take the 3 and I remove 2 of them, I'm left with 1. But what if I said 3 minus negative 2? Now what do you remove? Well, you can't remove negative 2's if you only have positives in your original group. So how do you deal with a question like this? Well, this is where most of us would say, okay, well, I understand that the minusing of a negative turns it into a positive, and that is exactly the same way polynomials work. So what we're going to do is we're going to do this like an addition. We're going to take this minus, and we're going to put it, and we're going to subtract all of these things from the original. We're going to combine like terms at the same time. So in this first bracket here, I have negative 2a squareds, and from it, I'm going to minus, right, this minus right here, the a squared that's in my other bracket, okay? Then I have plus a, and to it, I'm going to minus, so this minus is there, it's here, right? We're going to minus the negative 3a, and I have a minus 1, and from it we are going to minus that 2, right? So I'm combining my like terms, but as I am doing this, I am removing the bracket at the same time that I'm minusing these things. So instead of just removing the bracket and rewriting this equation with a plus symbol and no bracket, what I'm doing is I'm rearranging it, but as I move the ones that are in this second bracket, I'm writing them as a minus. So now I have negative 2a squared minus 1a squared, and that gives me negative 3a squared. I have positive a, or plus a, and again, minus my negative 3a. Well, how do we minus a negative? It turns it into a positive. So this is a plus 3a, which is positive 4a. And we have a negative 1 minus 2, which is negative 3. So it's not as simple as just removing your brackets when we're doing this question, and that's a huge mistake that I see all the way up to grade 12 students will do this. They will just say, this thing turns into negative 2a squared plus a minus 1 minus a squared minus 3a plus 2, and that is wrong. This is not a minus 3a plus 2 because this minus happens to everything inside this bracket. So we have to minus the negative 3a, and that turns it into a plus. And we have to minus the 2, and that turns it into a minus. So when I write this out as minus 3a and plus 2, I actually end up getting the wrong answer. It's a really, really simple mistake to make, but one that I want us to avoid. So when we are subtracting polynomials and we're trying to combine those like terms, make sure you're doing that minus to everything in that second polynomial. All right, how do I do this using algebra tiles now? And this is where understanding how positives and negatives work. Because what I can do if I wanted to do this using algebra tiles, well, I can make the first polynomial because it's not being subtracted. So 3s squared plus 2s plus 1, 2s, and then plus 4, 1, 2, 3, and finally 4. What I like to do the subtraction, so I have the s's and the ones that I could take away. So I could actually think about this like a takeaway. So 3s squared minus 2s squared, I'm simply just taking away the 2s squareds that I have, right? And 2s minus s, again, I'm simply just taking away this s that's already there. And 4 minus 1, again, I'm taking away the 1 that's already there. And when I do that, I'm left with s squared plus s plus 3. Now, that works if I have the tiles to remove. If I don't, so let's say I wanted to do question 4 instead. So I have my 3s squared minus 2s, so minus 1, 2s minus 4, 1, 2, 3, and 4, right? And I want to subtract from that my negative 2s squared plus s minus 1. So the minus 1, that's fine. I can do that because I have negatives that I can take this thing and I can remove it. But the problem is I don't have any positive s's here to remove, and I don't have any negative s squareds to remove. So I need to do something else with a question like this. Well, what does a minus do? And what is the difference in these two tiles? Well, these red tiles are just the negative of these positive tiles. So this kind of brings me back to that first question. I said, how do you do negative 2 minus 3? Well, we can think about it like negative 2 plus negative 3. So instead of trying to subtract these 3 and remove them when we don't have them, what we can do is we can flip them and turn them into their negatives. So what is the negative of negative 2s squared? Well, it's positive 2s squared. And what is the negative of s? Well, it's negative s. And what is the negative of negative 1? It's positive 1. So I can take all of these 3 terms inside the second polynomial, and I am subtracting them. So instead of thinking about it like a subtraction, I can think about it like the addition of their negatives. So I can take this negative 2s and I can turn it into the negative of negative 2s squared, and that turns into positive 2s squared. I can take my s and I can turn it into the negative of s, and that turns it into negative s. And I can take my negative 1 and I can do the negative of negative 1, and that turns it into 1. And if I do that, this turns into an addition. So now, group like terms, I have 1, 2, 3, 4, 5 s squareds. I have 1, 2, 3 negative s's, so minus 3s, and then I have 1, 0 pair here, so those cancel, and I'm left with 1, 2, 3 negative 1s, and I get 5s squared minus 3s minus 3. All right, so that is it for today's video on adding and subtracting polynomials. All right, I will see you all in the final video.